Hey, this is Tim here. We're looking at 11:21 Central, and I figured I would start up the stream here and take a look at some storms in the Palestine area. Looking at a few, they look like multi-cell storms right now. And you can see there's a very discrete appearance to each of these cells. And this has the appearance of a line multi-cell. And one other thing that we notice is that when we animate the imagery, there's a pretty fast movement of all the cells. You can see each cell is moving northeast probably at about 40 knots. So that means these cells are rooted in the mid-levels. If they were rooted in the lower levels, they would probably be tapping better moisture and instability. At this time, strongest storms, you can see a definite change compared to 45 minutes ago. You can see the cells back then looked a little bit weaker. We were struggling to find anything over 45 dBz's, just a couple cells here and there. And then 45 minutes later, to the current time, it's really filled in here. And the high-resolution rapid refresh actually did a pretty good job. It kind of nailed down development along this axis around 06Z, which is about 30 minutes from now. And it pretty much picked out this activity developing here. So let's see what we're looking at for tops on these storms. They definitely look shallow. Along this cluster, the highest top is about right here. It's going to be just northeast of Buffalo, up at 28,000 feet right here. I'll put a mark right there, and I'll go up one scan higher. Yeah, I can pick up a top right there. This is up at 37,000 feet, and nothing above that. So this looks to be the dominant storm right now. And that's going to be heading pretty much up Highway 79 towards the Palestine area. Don't have any severe thunderstorm watches or warnings on this. I don't think we have any watches. Let me take a quick look over at SPC. You can just go to your search engine and put in SPC NOAA, and that'll take you directly to them. And you can see we do have a slight risk, which is normally what we see with severe weather episodes. But we don't have any watches and no mesoscale discussions. So the thinking right now is no organized thunderstorms, nor organized severe thunderstorms tonight. But, you know, that you can't rule out an isolated thunderstorm here or there. And that's kind of what we're watching just for the next maybe half hour to 60 minutes. We'll just keep an eye on things. And further back to the west, this looks like the actual front starting to catch up to everything. That's it right there. We can probably see that very quickly on the surface plots from UCAR. And there they are. You can see the cold air coming from Canada, coming into Dallas right now and into Stephenville and almost down towards San Angelo. And the area of severe thunderstorms that we have right now, or marginal thunderstorms right now, it's out ahead of that front, kind of like that. And we can see that front coming on down from Oklahoma if I run this back. You can see it pretty well right here. This is the high resolution rapid refresh wind starting out here at 0Z, which is 6 p.m. The coloring corresponds to higher winds. So the highest winds are located right here along and south of I-40. And you can kind of follow the front as it makes its way south. Then by 3Z, which is 9 p.m., it's already gone past Wichita Falls, coming through Graham, and almost to Fort Worth and Dallas. And it looks like the high-resolution rapid refresh has it coming through there at 11:30 p.m., which is about right now. That's about right on the money right there. So that's what we're seeing here, is some forced convection along that cold front. And then the stuff here is just out ahead of it. Okay, what else can we look at here? Well, we can see that the thunderstorms look kind of disorganized on radar. How do they look on base velocity? Well, the velocity shows a lot of outbound. Everything's red. Of course, the radar is way down here. This is the Central Texas radar at Fort Hood. What we need to do is we need to subtract out the storm motion so that we can actually see rotational and divergent signatures, if they exist. And so the way we do that is we come down here and go to set storm motion vector. They look like they're moving about 35 to 40 knots, so I'm going to put in 240 at 35 and apply that. And I need to select the storm relative velocity. Yeah, this looks a little bit better here. Let me try to fine-tune that movement just a little bit. Let's see what 30 knots does. I need to go the other way. 40. Yeah, this looks good. So now what I'm looking for is areas of very high outbound and high inbound that form couplets. And one problem that we have going on here is a lot of range folding. You see all the purple here. That's due to a second trip echo coming back to the radar, and the radar can't distinguish between the two. So we end up with a lot of the velocities back here masked. And that's all past a certain range threshold right there. And they can fix that by changing the VCP, which is the volume coverage pattern, but there's no way to do that without going to the Weather Service and asking them to do it. So the only thing we can really do is change the levels or change sites. Changing levels, that helps a little bit. Let me change the storm motion vector a little bit. We've gone up higher, so we need to change that. Increase it up to about 50. And not really seeing anything here, really. So I guess I'll drop that back down. The important thing is we're not really seeing any very strong areas of very strong motion here. There's a variance of probably 5 or 10 knots around that cell there. So, and the other thing that I'm seeing here is there's not much of a reflectivity gradient. The cores of the storms are pretty well in the center of the echoes. I don't know if you can hear that thunder, but let me cut off the dehumidifier and I'll let you hear that. You may be able to hear a little bit of thunder in the background. Anyway, things are pretty disorganized right now. We're just watching for anything that rapidly comes together, anything unusual. I'll take a quick look here at the mesoscale forecast charts and just see what it shows. This is the high-resolution rapid refresh model for 6Z, which is about 30 minutes from now. You can see it pretty well nailed the position of that. I think there's an error how far south it went. As you can see, it kind of tapers off once you get past Buffalo and Centerville. College Station, pretty clear. Huntsville, pretty clear also. So Huntsville here, College Station here. That's right here. So a little bit of an error there in the high-resolution rapid refresh model. The linear position is correct, but the amount of back building is off. And there's always going to be some error in the mesoscale models like that. And back here is the cold front. So we got a couple viewers out here. Sarah and T. Gifford are on. Not much going on right now. Anyway, I'm going to take a short break and I'm going to put the music back on. I'll be back in a few minutes.
is lonely, sad and blue. Ain't got no love and shoulders to lean on. There's always a sunny side across the river. Take a ride, take a swim, and all your worries go away. Go cross the river and you'll be fine. Go counting winners, it's right down the line. You'll be alright on the sunny side.
All right, we're back here just checking out the precipitation. You can probably hear a little bit of that rain coming down outside. Currently looking at a kind of a weak line of thunderstorms, kind of a multicellular cluster in eastern or western Anderson County. Tail end of the storm right here around Oakwood, just northeast of Buffalo, Texas. And that appears to be the strongest part of this cluster. If you go up to the higher tilts, you can see that pretty much isolates where the main concern is right now. So this is going to be a top going up to 31,000 feet. Some of it touching up near 42,000 right there on that last scan. And that pretty much tracks down to possibly that cell right there. I was looking at the KDP, which is it's one of the duopole products that appears to differentiate a little bit better what's going on in that line. Seems like we get a couple different clusters right here, 3 of them. So I was taking a look at that briefly. And we'll see if spectrum width is showing anything. Probably not. Usually this far out, spectrum width isn't really anything interesting. Usually if you're closer to the radar, that's where you start seeing interesting features. Okay, let's see what the instability indicators are from the high resolution rapid refresh. That'll give us some idea what the possibility of severe weather is in further on in deep east Texas and Louisiana. Looks like the latest product we have is 4Z. It only goes out to about 5 in the morning. And this time of the night, probably the best indicator to use will be probably the mixed, maybe the mixed cape. Yeah, we'll do that one. Okay, so there's our cape from the high-resolution rapid refresh, the 03Z run. You can see it calibrated down here in joules per kilogram. And 1,000 of 1,500 are considered threshold values for thunderstorms. So we're talking about aquamarine blue. And we've only got a thin sliver of that coming up to Dallas. And as we go on through the night, there's midnight, there's 3 in the morning, and there's 6 in the morning. So we can see the instability drops off quite a bit and is mostly confined to the area west of Houston, out in this area here. So it looks like the chance of severe weather in Louisiana and deep east Texas will be low. And there's a lot of situations like this where the line kind of goes to town once it moves eastward, but it looks like tonight is not one of those nights. So we're at about right here, and the line is located something like that. Not really extending all the way down to the better instability. So there's only a limited window that we have for any severe cells, and it looks like that's going to be confined to the I-45 area here on the tail end of those storms that we have around Anderson County, around Crockett. And the forced thunderstorms coming into the I-35 area, I'm not really sure that those are going to do anything. Looks like we got a few cells trying to get going around the Franklin area. Right here, that's just north of Hearn. There's College Station, Texas A&M University right there. And that's where the instability is down here, but it looks like there's just enough capping to keep things suppressed. Okay, we'll check out a couple of more products here. I think the instability kind of tells the whole story, but we might be able to check a few other products here. Like we can see what the low-level jet is doing by looking at the 850 millibar wind. So for 12Z, the 850 millibar wind is going to be looking like this. And this is showing some pretty decent cold air advection coming into Dallas-Fort Worth. See that right there? Very strong northerly winds coming in from Kansas and into western Oklahoma. And we can see 45 knots there at Dallas-Fort Worth, so might be a bit of a bumpy ride for anybody flying into DFW Airport tomorrow morning. Certainly some wind shear there. And that's going to be back behind the cold front, which is probably going to be pushing rapidly through East Texas and down to I-10. And I don't think I see a low-level jet really, but I don't know, that might be one right there. Just the remnants of a low-level jet out ahead of the front. I'm going to take a quick look at the 850 millibar loop because that's kind of interesting. Okay, so there's the initial panel there, 850 millibar at 9 in the morning, or 9 in the evening. And yeah, we've got a low-level jet in place. 9 p.m. right there, basically from Tyler and Lufkin all the way up to the Ozarks. 40 to 50 knot flow there. And out to the west we can see the cold air advection coming in from Kansas, and the leading edge of the cold front is running something like that. And as we move forward to midnight, and then 3 in the morning, and then 9 in the morning, we can see that cold air advection pushes south, and the low-level jet, what little we had, is out of the picture, well to the east. And we'll see what kind of temperatures are coming in with that very strong cold air advection. Okay, the start of the map is right there. And anything blue is 40 or below. Anything yellow is 60 or above. Okay, so obviously that's yellow, so that's 60 or above. And anything blue, that's going to be way out here, that's 40 and below. So we'll run that forward. So here we go through the overnight period. There's 3 in the morning. There's 6 in the morning. And it looks like very strong cold air advection, but very strong insulation. Very strong heating from the sun. Looks like that warms things up in that cold sector. So we're looking at lots of 50s through here and lots of 40s through here around midday tomorrow. So we'll be on the blustery side, but just a little bit nippy, kind of like jacket weather it looks like. And looks like we warm up to 60s and mid-60s, upper 60s across much of North Texas tomorrow. So I guess we got shortchanged on winter yet again. All right, let's check on the storms. That's the best way to assess changes, is to walk away and do something else and come back, and then you can really see the changes a lot better. So it looks about the same here. Let me look up the KDP. Kind of showing one big cluster right there south of the Trinity River Bridge. I-70 or Highway 79 across the Trinity River right there. And probably the higher tilts are going to show that too. Looks like we just stepped forward a little bit here. We got the 552 frame in. So there we go. There's our higher, there's our main core right there up at about 32,000 feet. There's 42. And that's going to be right over Long Lake. There's 79, there's 294 going to Elkhart. And the core of that storm is right over that intersection. And that's continuing to propagate slowly eastward. And what do we look like further down the line? Not a whole lot going on. Go up to the higher tilts and see which cells stand out. We've got one here near that power plant north of Jewett. And we got another cell north of Franklin. And that's it for the warm sector, and here comes the forced lift along the cold front. That really stands out pretty good there. Cells all the way from Greenville all the way back to Mason in the hill country. And we're probably going to see a very strong velocity shift across that front. And there it is. See all that green back there? That's inbound velocities coming towards the radar from the north. Whereas close to the radar in the bulk of the warm sector, here the green, which is strong inbound velocities, is coming from the south. So this is showing that we have winds out of about 200 relative to true north coming from the south. And then looks like our brighter green shading is in this area, maybe right here. So this is suggesting winds out of 310 in the cold sector back here coming towards the radar. So two different regimes of different wind directions. And we'll check out the velocities on these cells around Palestine. Showing a very weak rotation right around here. Looks like a very faint couplet. And there it goes right there. Yeah, I think that's probably a weak couplet. So we're showing about 6 knots outbound. That's not very much at all. Let me show you how I'm computing that. You can see on the very bottom there's this readout here. And we get two numbers. One is the readout of velocity and the other is the maximum unambiguous velocity for that VCP. So the one I'm really looking at is this one right here. And I set that on that couplet and I get 7 knots outbound, and then up here I get about 13 knots inbound. And what I really want to see for a severe thunderstorm is maybe like 30 knots outbound and 30 inbound. So we're not seeing a whole lot in the way of severe weather here. So let me play around with this real quick. probably hear a little bit of that thunder out there. So there's that couplet. That's going to be about a mile south of the 79-294 intersection right there. And that's going to probably be tracking towards South Palestine. And by weak couplet, I mean pretty much nothing to worry about at all. Center of the couplet is right there. This is about 11,000 feet up, so can't get any lower than that because we're pretty far from the radar. And that's about where we would expect to find a couplet. That's going to be around the inflow region of that cell right there. So most of this is all a downdraft, and then in here is going to be an updraft area, and that's where we're finding that couplet, that very weak couplet. Then do we have anything above that? A little bit. Looks like maybe a little bit of weak rotation here. Then that gives way to a little bit of divergence, but it's a very noisy signature there. So we're squeaking out a little bit of a moderate thunderstorm out of this stuff. And there it is over the 294 area around Lakeview. Some sort of Methodist retreat somewhere in here. That's about where that storm is. Here's County Road 2110. Here's 294. And here's 322. So the updraft area of that storm is going to be located about right here. Right in this area, that's the updraft. Downdraft is located something like this. So if I was concerned about severe weather, I would probably be focusing on this area right here. And I'd be looking at that drifting northeast this way, about halfway between Elkhart and Palestine. And we got a few more popcorn thunderstorms developing back behind here. So we're still pretty deep into the warm sector. All of this is the warm sector right here. There comes the cold front coming through Dallas, clearing Mesquite, coming through Waxahachie to the split at I-35 at Hillsboro. And just west of there, this is around the Bush Ranch, west of Waco, northwest of Fort Hood, and front coming in through Llano and Mason. So right now, it looks like the strongest stuff is right over right over Palestine. And the signature on the storm relative velocity looks a little bit weaker. There it is right there, still south of 294. And I'll take one more short break, and we'll see how things look. Okay, at 12:07 a.m., we're just taking a quick look at what's left of this area of thunderstorms. You can see it's mostly concentrated on the area from Texarkana down to Tyler and Palestine. And I was just looking at the Shreveport radar, and we've got more of a coherent squall line. You can see it extending from about Hope, Arkansas, south of Texarkana, and east of Longview. And this is showing a little bit more of the reflectivity gradient that we like to see with severe weather. Of course, it's very difficult to get severe weather out of a strongly two-dimensional squall line like this. But there's a bit of that very strong reflectivity gradient right there. So if I was looking for localized severe weather, I would probably be a little bit concerned with that area right there. Also areas like this, I don't know if that's showing. Yeah, looks like it is. Up here, reflectivity gradient there, strong gradient there, strong here, and then it's actually weaker like here. There it's weak. And here it looks like it's weaker. So that's one way you can distinguish when you don't have very good radar data or good access to velocity products. And it looks like the whole area all the way down to Tyler and Palestine starting to fill in a little bit. Then our view down from the south looks like that. So we're basically just forming kind of a broken line of showers and thunderstorms, kind of disorganized. And very likely this front will start catching up with things later on. Now the chance of severe along the cold front is going to be kind of weak, because when you have very strong thermal contrasts across the front, even at storm scales like this, that will give you storm characters kind of like what you see with outflowish thunderstorms. That'll tend to undercut updrafts very quickly, and so if you do get tornadoes starting to develop, they'll be strongly undercut, and that will interfere with any tornado development or any strong multi-cell thunderstorms you have going on. So I'm not really too concerned with this back here. So we looked at the instability on the high-resolution rapid refresh, and that showed most of the stronger instability was concentrated down in this area of Texas, and that area is also pretty well capped, so that may be it as far as severe weather. We were looking at not much of an instability out here in Louisiana, so this is the very brief window I had referred to earlier. And as far as geographically, we're only talking maybe about a brief area like that. Marginal area of possible severe weather, and even SPC is not really going for anything. We'll take a quick look at them. I don't know if you can hear that rain outside, but it is coming down. And there we go. Watches, no convective watches. Mesoscale discussions is what they issue when they're thinking about a watch. Nothing there either. So everything looks pretty quiet there. Then their convective outlooks are looking like this. The outlook that continues for the next 6 hours. There you go right there. The slight risk ends at about Shreveport to Lufkin. And then after 6 a.m., this is what we're left with, just kind of a marginal area of potential for severe weather. And then you can read their discussions here. They're talking about severe thunderstorms are unlikely. And then they'll explain the reasoning there. And let me read this real quick. And there they're talking about the clusters, quasi-linear convective segments ongoing at the beginning. And that'll move through and a bunch of stuff and so on and so on. Mixed layer CAPE, 500 to 750, which is very low. That's in the thunder shower range. So, but they're pointing to a little bit of flow hanging on there, so they're thinking that might squeak out a few possible weak cells, but not much else. Poor lapse rates in the boundary layer. That's basically just weak instability. And that's pretty much how it looks there. And I think that's probably about all I got for tonight. This was kind of like a test run. But when we have severe weather going on, another event maybe in December or January, we'll go ahead and fire this up and maybe do some more of these severe weather webcasts, and we'll see how that goes. Anyway, hello to everybody in chat, Sarah and T. Gifford and Counterpoint Interval from Dayton. Yeah, I was out there about 10 years ago. I tried to make it to the Air Force Museum and see the planes. I always wanted to go there, but I didn't have time to make it out there. But next time I'll hit that museum up. Anyway, that's it for here, and I appreciate it, and we'll see you tomorrow at 8 o'clock for the usual scheduled webcast. Thanks for watching.